Thanks everyone for coming. Thanks also for the organizers for inviting me. I indeed want to apologize for changing the title at the last minute. There are two reasons for this. The topic that I had in mind when I gave the previous title will remain the focus of this talk, so it's not like you have lost everything. The reason I changed the title is twofold. One is shortly after I gave the title way in advance, I stopped liking it. And the second one is that when I was preparing the slides, I didn't remember the title that I gave. And so for this reason, you have a new one. But the topic is the same. And indeed, I should say that the topic of today will be developed in the three talks that are coming up will culminate on Wednesday. So there might be some questions that you'll have after this talk that I hope to address at least in the last talk on Wednesday that I'll give. All right. The title is, of course, an allusion. The one that you have here is, of course, an allusion to a paper by Chomsky called Some Evo-devo Theses for the Language Faculty, where he revisited some of the issues that he addressed with Hauser and Fitch in the famous or infamous, depending on your allegiance, 2002 Science article. And I want to basically take that paper, or indeed the Hauser, Chomsky, and Fitch discussion, as a starting point for this talk, and tell you that the many people who have sort of followed the Hauser, Chomsky, and Fitch line, and they seem to me to be many in the generative camp, have been wrong in many ways. That is, there are serious problems, I think, with the way questions were framed in the Hauser, Chomsky, and Fitch paper, and I'd like to correct at least some of them today. Just to help you follow the talk, let me give you just two warnings. The first one is there's not going to be any specific data from any specific language in this talk. This is a tradition that I usually follow when I come to Japan. And I usually say, and indeed I believe that this is progress for biolinguistics, that is, we should move away from specific languages and focus on the language faculty instead. And the second hint or help that I'll give you is that this talk will in part address a point that Ray Jackendoff has made several times when he said that when you do biolinguistics, or specifically when you study the evolution of language, what you do when you address that topic depends, according to Jackendoff, and he's right, on the type of theory of language that you have in mind. That is, your view of language will also affect your view of biolinguistics or your view of the evolution of language. This is close to a truism, but what's not often mentioned, and what Jackendoff certainly doesn't mention, is that your view of the evolution of language or of biolinguistics also depend on your view of what biology is or what evolution can actually give rise to. And that's usually sort of taken for granted by linguists in particular, but I think that there are reasons for being as open on the biology side than we should be open on the linguistic theory side, and this is what I will try to do today. So I will start with sort of a brief description of some of the activities that take place in evo-devo research, so the field on evolution and development. And I'll start with an authority in the field, Müller from Vienna, who says that the organismal form, shape, morphological structure, and the generative mechanisms underlying their evolution represent the essential questions within evo-devo. So if you want to explore certain evo-devo theses, make sure that those theses pertain to the topics that I just mentioned. And of course, if you're generative grammarians, you must feel very happy that the word generative came up in this quote. It's not innocent, of course, but it's not as related as you might think to generative grammar. Okay. And one of the key issues in evo-devo is figuring out the origins of novelty, both in development and in evolution. On the right-hand column, you have a particular illustration of novelty having to do with basically a novel complex phenotype that people have been worrying about. And they've realized that the origins of novel complex phenotypes, and if you think of language, this is good, represent one of the most fundamental yet largely unresolved issues in evolutionary biology. As everybody in this room, I'm sure, knows, when Darwin wrote The Origin of Species, he did not address the origin of species, right? He actually said somewhere that the origin problem is too hard, so let's leave it for somebody else. Okay? And it's often stated in the evo-devo literature that while biologists have made great progress over the past century and a half in understanding how existing traits diversify, relatively little progress has been made in understanding how novel traits come into being in the first place. And here I'm not talking specifically about a very famous, perhaps the most famous topic in evo-devo having to do with the conservation of genes, like for example Hox genes. I'm talking about not so much the genetic basis of novelty, but simply how novelty could arise even outside of a genomic framework. Okay, so the picture that I showed you earlier, this one on the right-hand side, has to do with beetle horns, which is a class of traits that lacks obvious homology to traits in other insects. And it's been well demonstrated that these horns are remarkably diverse in their expression, male and female differences, and even differences across various species, both pertaining to location and also shape of the horn. Okay, but it's also known that while we have this diversity and this novelty in that particular realm of biology, at the same time beetle horns share aspects of their development with that of more traditional appendices. So here we have an example out of many of a novel trait that's both so different from anything else that we want to say is very specific and distinct, but at the same time biologists recognize that this novel aspect also is not completely novel, that it shares properties with other things that you find in other species. And the question is, of course, whether when I tell you this about the beetle horns, whether you were tempted to think about this paper by Hauser, Chomsky, and Fitch, where they introduced the famous FLN-FLB distinction, recognizing that there are some aspect of this trait that we call language, that aspects that are novel and other aspects that are shared. In this particular framework sketched in Hauser, Chomsky, and Fitch, based on the FLN-FLB distinction, seems to me to have been taken as a starting assumption, or as a good framework for framing questions in biolinguistics, and especially given the definition of novelty that we find in the evo-devo literature. So this is outside of language. This is again by Müller and a friend of his, Wagner, in 2001, who defined novelty as follows. A novelty in the biological world is a structure that is neither homologous to any structure in the ancestral species, nor homologous to any other structure of the same organism. Okay? So if you start thinking of FLN as something that is both unique and specific to language and to humans, you fit right in there in the definition of novelty. So according to, if you've read Müller and Wagner, and you have read Hauser, Chomsky, and Fitch, you might be tempted to say, well, the Hauser, Chomsky, and Fitch is a great evo-devo paper. It sketches a program centered on the distinction between FLN and FLB, and especially the FLN part fits precisely in the definition of novelty or novel trait that has been given independently in the biology literature. So isn't it great we are finally doing biology, you might say, if you've read the Hauser, Chomsky, and Fitch. And I'll tell you it's wrong. That is, I'll tell you that even though the Hauser, Chomsky, and Fitch paper at times reads like an evo-devo paper, it is not an evo-devo paper. And in fact, it fails in many interesting ways that I think could be corrected so that it could become an evo-devo paper. And this is what the title, Some Other evo-devo Theses for Language, was alluding to. Okay? So this is the FLN-FLB schema that appears in the 2002 paper. I'm not going to go through it because I'm sure most people are familiar with it. But I will come back to certain particular aspects of that schema at various points in the talk. In particular, the fact that Hauser, Chomsky, and Fitch at various times in the paper, both in the 2002 paper and in the 2005 reply to Pinker and Jackanoff, place FLN as a proper subset of FLB. And this I will take issue with. Okay? Just to be on the safe side, I'll repeat a couple of things that Hauser, Chomsky, and Fitch mention in their paper so that it's common knowledge among all of us, and then we can debate whether it's really as they say or not. Hauser, Chomsky, and Fitch point out that something about the faculty of language must be unique in order to explain the differences between humans and the other animals. So a running theme of the paper is the uniqueness of at least some aspects of the language faculty. And they continue pointing out that linguists and biologists, along with researchers in other fields, can move beyond unproductive theoretical debate to a more collaborative effort if actually they recognize a distinction that they introduce or that they make really important, the FLN-FLB distinction. I've hesitated a little bit, like a moment ago, in saying that the FLN-FLB distinction was introduced by Hauser, Chomsky, and Fitch. The reason for me doing so is because actually someone else introduced the FLN-FLB distinction, and it's actually, ironically, Ray Jackanoff in 1987, where he proposed something similar. Okay? But the important thing about this quote is Hauser, Chomsky, and Fitch insist that if you have an FLB FLN distinction that's very clear in your mind, then you can move beyond unproductive debate. Right away, I want to point out that, as you probably have realized in the intervening years, the debate surrounding the Hauser, Chomsky, and Fitch paper hasn't particularly been of the productive kind, one should say. So perhaps they were wrong about this. And as far as I can see, most of the debate, most of the substance of the debate revolves around how to define the FLN-FLB distinction and what to put in it. And I'll tell you that the reason that debate has been unproductive is the FLN-FLB distinction wasn't a good one to begin with. Okay? Nevertheless, in Fitch, Hauser, and Chomsky 2005, they say that it seems likely that some subset, right, and here I stress subset, of the mechanisms of FLB is both unique to humans and to language itself. And this subset of mechanisms is what they call FLN. So it's both unique to humans and to language. Okay? This is a slide reminding you of the fact that, if anything, Hauser, Chomsky, and Fitch should have talked a little bit more among themselves before writing the paper, at least when they described the content that they were tempted to put in FLN, because here are like 4 different passages of the original 2002 paper giving you different things included in FLN. Sometimes it's only a recursion, sometimes it's recursion and the mapping, sometimes it's at least recursion, and so on and so forth. Okay? And this has been part of the controversy, but I don't think that this is the particularly, like, the most problematic aspect of the paper. As far as I can see, even people taking issue with the recursion thesis as FLN assume that there is something right about the FLN-FLB distinction. What people debate is what fits in FLN or what fits in FLB. Okay? And again, just to emphasize, they really state that this FLN-FLB distinction is crucial for protective biolinguistics, if you want. Okay? So it came as a surprise to me that one of the three authors of the Hauser, Chomsky, and Fitch wrote in 2010, not that many years after the paper, the following. Here's two excerpts from Fitch 2010. What all of these examples, and you don't have to know about them, it's in his paper, make clear is that the distinction between general and linguistically specialized mechanisms is hard to draw. True. Even in those cases where the mechanisms themselves seem fairly clearly defined, most areas of language are not and will not soon be so clearly defined, and thus the distinction itself, that is between general, shared, and specific, unique, the distinction itself is of little use in furthering our understanding of the mechanisms. This is Fitch talking, basically concluding that something like the FLN-FLB distinction is not useful for biologically informed debate, if you want. Okay? And he goes on saying, arguments about whether the constraints are general to cognition or specific to language or to humans are, in my opinion, unlikely to help resolve the substantive biological issues involved in understanding the FLB. And when you read this, you should scratch your head and start, but isn't it the guy who said that the FLN-FLB distinction was crucial for productive debate? And yes, that's the guy. Okay? All right. In that literature surrounding the FLN-FLB distinction, you find many passages like the following. This is taken from a recent Nature Reviews paper about bird songs, concluding the paper by saying, perhaps this is a good time to reconsider whether attempting to distinguish between qualitative and quantitative differences is helpful if the quantitative advantage is vast. So they are talking about basically FLN-FLB, and saying that perhaps we should reconsider the usefulness of this distinction. Okay? Jackanoff and Pinker made an early point, roughly along these lines, saying that the narrow-broad dichotomy, which makes space only for completely novel capacities and for capacities taken intact from non-linguistic and non-human capacities, omitting capacities that may have been substantially modified in the course of human evolution. And then they go on saying that distinction is not so good, precisely because it seems to exclude a couple of possibilities that one may want to consider. The distinction, and I think Jackanoff and Pinker are right about this, is very sharp indeed. That is, they want to say either it's completely novel or it's completely shared. Okay? And they claim that with this FLN-FLB distinction, some hypotheses, in their view, Jackanoff and Pinker, the most plausible ones, become impossible to state, or at the very least, very, very difficult to state. And this is a point that I will emphasize because I think Jackanoff and Pinker were on the right track here. That is, they were correct in pointing out that there are some biologically plausible theses about language or organisms in general that one wants to state or one would like to explore, but they are very, very hard to state given the FLN-FLB schema that's in the Hauser, Chomsky, and Fitch. Okay, namely this one where FLN is a subset of FLB. And I'll give you a hint first, and then I'll give you more details further. Consider this picture. This is a famous painting that many of you, I'm sure, know. You immediately recognize that this is someone's portrait, but you also recognize that the portrait, at least if the image is clear enough, that this portrait is composed of vegetables arranged in a particular way. And so you might, if I were to ask you, what is this, a portrait or a bunch of vegetables arranged in a particular way, you might be hard-pressed to give me a satisfactory answer. In some respects, it's a bunch of vegetables, but it's also something more than that. That is, the arrangement gives rise to a particular entity, in this case, the portrait, and it would be hard to say that the portrait is a subset of the arrangement of vegetables. Okay? And likewise, I'll tell you that putting FLN as a subset of FLB makes it difficult to entertain certain things certain hypotheses according to which FLN could be like the conjunction of things that are shared with other species but that are uniquely arranged in humans. All right. Yeah. There is another problem, I should say, with the Hauser, Chomsky, and Fitch paper. Namely, they say, at least at one point in the paper, that FLN comprises only those core computational mechanisms of recursion as they appear in narrow syntax and the mappings to the interfaces. Jackanoff and Pinker pointed out that the claim is rather uninteresting because mapping to the interfaces is left vague in both articles, that is the 2002 and the 2005 articles. And this is true, but what is also left vague is this part. Namely, when Hauser, Chomsky, and Fitch talk about the core computational mechanisms of recursions. Nowhere in the 2002 paper, nor in fact in the 2005 paper, are we given those mechanisms. That is, in the absence of the actual mechanisms of recursion, it's very hard to actually debate the issue. Okay, and I think partly this accounts for why people have been debated, is recursion unique to humans or unique to language? It's because in the absence of mechanisms, it's very difficult to test that particular claim. Okay? Yes, I'll skip some parts. Okay. And what I would like to tell you is that what I said already at the beginning of the talk, one of the things that one should do in order to do, I think, proper biolinguistics is not so much worry about the type of theory of language that one assumes, but also the type of biology that one assumes. That is, very infrequently do linguists turn to the non-linguistic literatures to see whether what they are saying actually makes sense. That is, one should ask, is the FLN-FLB distinction sound on biological grounds? Forget about the linguistic grounds, but how about more general biological grounds? And I think that here we'll see that the distinction is not quite so well-founded. Precisely because we are not given many of the mechanisms in the original papers, and that makes it very difficult to combine the Hauser, Chomsky, and Fitch hypothesis that at first looks like an evo-devo paper with the actual evo-devo literature where mechanisms matter a lot. One thing that I should mention in this context is what Fitch, Chomsky, and Hauser write in 2005, that is the subsequent paper. They say something about like this: something about the faculty of language must be unique in order to explain the differences between humans and the other animals. So far so good. This is something that I've already quoted from. But then they add, if only, so they say, what is unique? Well, perhaps it's only the particular combination of mechanisms in FLB. Okay? So they recognize this as a possible state of affairs. That is, what make language special is the particular combination of mechanisms, all of which would be shared. That is, all of which would be part of FLB. But then, if this particular combination of mechanisms, part of FLB, gives rise to what's specific to language and specific to humans, then it's very hard to still insist on FLN being a subset of FLB, right? As I'm sure is very clear to every one of you. Okay? So here's a hypothesis that I should state right away is actually the hypothesis that most biologists would actually favor, especially in the evo-devo literature, for reasons we'll see. So here is a hypothesis that Fitch, Chomsky, and Hauser recognize, but what they fail to recognize is that there is a discrepancy between this particular hypothesis and the schema they proposed in 2002. Okay. Chomsky has occasionally thought about this possibility, namely that FLN, well, or, you know, this is an anachrony, but what we today would call FLN would be just the result of a combination of FLB ingredients. as far as I know, he first thought about this in Rules and Representations in 1980, but he came back to this possibility in a more recent paper in 2000 and says this. Now, a question that could be asked is whether whatever is innate about language is specific to the language faculty or whether it's just some combination of the other aspects of the mind. Chomsky says that this is an empirical question, thank you very much, and there is no reason to be dogmatic about it. Okay, we do science, not religion. You look and you see, he says, although it's, of course, more difficult than you just look and you see, right? But Chomsky insists that what we seem to find is that it's specific. That is, he insists that there is something that's not shared, right? And think about this portrait again, because we'll come back to it, okay? But when you turn to the evo-devo literature, they tell you that phenotypic novelty is largely reorganizational rather than say a product of innovative genes. That is, very often the way you get novelty is by recombining all parts. Okay, and if you make FLN, if you try to say FLN is that, but FLN is a subset of FLB, it's very hard. Okay. All right, so now I'm going to move to the biology literature and give you snippets of that literature to show you that Hauser, Chomsky, and Fitch put us on the wrong track. Okay? I repeat the definition of novelty, so a structure that's neither homologous to any structure in the ancestral species, nor homologous to any other structure of the same organism. So neither specific to humans, nor specific to language in the context of language. That would be FLN. Okay? Now, I should say as well that novelty is really an evo-devo focus of research. Before the rise of evo-devo as a productive field of study, novelty was considered an explanatory deficit of the modern synthesis. That is the consensus view in biology until about 20 years or so ago. Ernst Mayr, sometimes called the Darwin of the 20th century, wrote the following in 1960. He's one of the few people who actually identified novelty as something to worry about for biologists, even though it seems so obvious, but, you know, at the time it wasn't so obvious to many biologists. And Ernst Mayr had this to say: the problem of the emergence of evolutionary novelties has undoubtedly been greatly neglected during the past 2 or 3 decades, in spite of its importance in the theory of evolution. But then what he says is that it's been neglected and we have very little to say about it. Okay, 1960. That is, until the rise of evo-devo, there wasn't much of a theory about how to think about these evolutionary novelties. The modern synthesis was great with things that were already in place and then diversified. They were great in saying, in this particular ecological context, this particular variant is selected as opposed to that other particular variant. But how those variants emerged in the first place, that was left for somebody else. Until people like Müller came about and began to be clear about what novelties could be, and crucially, what would be the mechanisms that give rise to them. And Müller distinguishes among 3 types of novelty, so 3 different circumstances in the biological world under which we might want to use the word novelty. The first one, that he calls emergent novelty, is refers to essentially the very beginning of life, of biological life, where multicellular assemblies came about. And Müller says this is a type of novelty that we would like to study. That is, how come that unicellular organisms basically got together and gave rise to a multicellular assembly. Type 2 novelty is way past the origin of biological life, where discrete new elements emerge, for example, the horns, and after talking to Müller, I can tell you that he would also place language in there. And then there is a type 3 novelty, which is an individualization of existing elements And that, according to Müller, is called variational novelty, and it's the sort of thing that the modern synthesis was very good at dealing with. How certain variants got selected, and then a particular configuration of the population emerged. And type 3 novelty basically is good style, traditional modern synthesis-based biology. And what evo-devo focuses on is type 1 and type 2. And in fact, more specifically type 2. They try to understand how discrete new elements got into body plans, for example. Okay? All right. And I'll give you a couple of examples of how discrete new elements are dealt with in the literature. Again, the horns will serve as a good example. For example, this paper by Moshek and Rose, a very recent one, but I think very comprehensive, talk about differential recruitment of limb patterning genes during development that give rise to certain horns that don't seem to be shared in the biological world. What they do is actually demonstrate that differential co-option of appendage patterning genes during the evolution could actually give rise to novel structures. But what they crucially then stress is that what's being recruited is, of course, shared with other species, but a particular type of recruitment or a particular type of organization of these structures give rise to novel traits. Okay? And so, crucially, they wouldn't say that the horns or the mechanisms responsible for the horns are a subset of shared ingredients for that particular capacity. Okay, I'll skip this part. It's just to give you two or three more examples where people really assume that you can only get discrete new elements from what's already available and shared with other species. Okay, that's actually contrary to. So it's a little bit ironic that the Hauser-Chomsky and Fitch paper was written, at least in part, because it was thought to be more in line with the biology of the time, more in line with the story of descent with modification that Darwin would have favored. But actually, the way they phrased the distinction, insisting on the uniqueness of FLN, I think makes that particular project fail. Okay, I'll skip some parts, and I'll give you now a very brief sketch of how Alan Turing asked us to think about biological novelty. And you'll see that if we had followed Turing's thesis, we would have come up with something very different from the Hauser-Chomsky and Fitch hypothesis about FLN and FLB. I put on this slide Turing's real thesis, real in bracket, because this is also a quote from a recent Chomsky talk, at least, where he talks about Turing thesis. And I think that the Turing thesis he has in mind is actually different from the thesis that Turing had in mind. And you'll see why. The particular thesis that Turing proposed goes back to 1952 in a paper on morphogenesis that's well known in the world of theoretical biology, at least, and that could be, I think, a good source of inspiration for biolinguists. And the paper focuses on patterns of coat patterns on various animals, the big cats, the frogs, the zebra, and so on. Turing was very much intrigued by these patterns. He recognized them as novel structures, and he wanted to understand how these patterns emerge in a mechanistic way. That is, he didn't want just a description. He wanted to provide mechanisms that could give rise to these patterns. Okay? And this is actually the equation that he proposed. I'm not going to go into the details. There are basically two mechanisms that Turing needed. One is local autocatalysis and lateral inhibition. And these are the two equations that give rise to basically the patterns that you find on the big cats. The details are not important for today. They will become more important for the talk that I'll give on Wednesday. But what's important is how biologists read Turing's paper these days. I'm going to give you passages from a very interesting paper by a theoretical biologist at Oxford, Philip Maney, who talks about the impact of Turing's work on pattern formation in biology. And I will relay these quotes to the Hauser, Chomsky, and Fitch paper. Here is what Maney says about Turing's hypothesis. Remarkably, Maney said, Turing showed that under certain conditions, a system could exhibit spatially uniform steady states which were stable in the absence of diffusion, but which were driven unstable by diffusion. Diffusion is basically the core result of the interaction between the two equations that I gave you earlier. And what Maney said is that Turing's hypothesis, his central thesis, is actually highly counterintuitive, because basically it says that one can take a system which has a stabilizing reaction kinetics, add to it diffusion, and the resultant system becomes unstable. That is, you put two stabilizing components and you let them interact, and surprisingly, the interaction gives rise to instability. And this is what Maney is highly counterintuitive, because, and now you'll see the connection with Hauser, Chomsky, and Fitch, sometimes when you put ingredients that have properties of their own and you let them interact, the resulting picture is unexpected. Even though you know properties of each and every individual component, the interaction of these components gives rise to structures that cannot always be predicted from the properties of those components. And I think this is a thesis that Hauser, Chomsky, and Fitch failed to take into account in the context of language. Maney is right to show that Turing probably gave an example of an emergent property, that is, two stabilizing conditions giving rise to instability. Okay? And showed, that is Turing, that complex phenomena can arise as a result of the integration of fundamental units, each one of which lack the properties that you want to explain ultimately. And biologists are now beginning to realize that identifying the individual components, for example, like what people do following Hauser, Chomsky, and Fitch, is this component part of FLN? Is this component part of FLB? Well, biologists are now beginning to realize, actually they have realized it for 20 years, that identifying the individual components is not enough, and that in order to understand the process of development, it's essential to see how these individual components interact. This is something that's absent from the Hauser, Chomsky, and Fitch discussion and subsequent literature. Okay? I'll skip these parts, okay, and stress one thing, and I think I'll have to conclude after this, is that the origin of novel traits is indeed what draws many to evolutionary biology. And I think that FLN is really what draws many to not only linguistics, but to biolinguistics, okay? But in order to understand the origin of novel traits, okay, it's very, very important to be clear about the mechanisms that underlie the genesis of novelty. And the main message I wanted to give you today, if only to prepare you for the hypothesis that I sketched on Wednesday, is that even though the Hauser, Chomsky, and Fitch paper sort of primed this topic of evolutionary novelty, defining FLN exactly like the way novelty is defined in the evo-devo literature, they never they failed to do two things, which is why I think they don't provide a good departure for biolinguistics. One is they fail to provide the mechanisms, for example, those that underlie recursion. They specifically talk about mechanisms of recursion, but they never say which ones they are. In the absence of mechanism, you can't go very far. If only because in the absence of the mechanisms, you don't know how shared components could interact in a particular way to give rise to novelty, following Turing's thesis. Secondly, they basically placed FLN as a subset of FLB, and that I think was a mistake, because it prevented if you follow that framework, of course, it would prevent you from actually looking into hypotheses, for example, like the one Turing suggested in 1952, where shared components have whatever properties they have in isolation, but once they interact, they give rise to unexpected results. This is something that you can't do if you adopt the FLN-FLB distinction, because if you start with shared components, you'll be talking about FLB, but their interactions may give rise to what you would be tempted to call FLN. And as a result, whichever way you go, you won't be able to say this is FLN or this is FLB. It's actually both. And so on this note, I will end urging you to reconsider what many take to be a good framework for biolinguistic discussion, for fruitful, biologically informed linguistics, and consider hypotheses, for example, like the one Turing gave, and come Wednesday for a particular instantiation of Turing's thesis. Thank you.